In interpolation and extrapolation, we have two methods to solve. First one is binomial expansion method, where we use Pascal triangle and we use that Pascal triangle numbers as the coefficients and elaborate the equation and solve them. So in interpolation, we will be able to find the missing numbers. In extrapolation, we'll be able to forecast the next year data also. So that was interpolation and extrapolation. Now coming to the second type or second method, which is known as Newton's advancing difference method. Now, this method also can be asked for examination, but more of binomial method will be asked. But I have seen, I think out of 5 papers, at least 3 papers, they have asked one question out of Newton advancing difference method. Okay, so let us understand what is this Newton advancing difference method. This method is applicable in those cases where the independent variable increases by equal intervals. So here the independent variable, that is x, will increase in equal. So the gap between the first and the second year and the third year and the fourth and the fifth and the sixth and so on will be equal. So if you see here, there is a gap of 5. 5, 10, 15, 20, 25, 30. So the x values will have equal interval. Now, whenever you have x values with equal interval, then in that case, you have to use Newton's advancing difference method. Okay, so unlike binomial expansion, it is not necessary that the value of y is to be interpolated, must be one of the value of x. So in binomial method, at one point of time, we will have to check the x and y values and the value will be present there only. But here it is not necessary. The only condition is the independent variable, that is x, should have equal interval. Now, if you see y here, it is different. 4, 5, 6, 7, 8. Then after 8, immediately 9 is there. Then again 2 differences there. Okay, so y can be of any interval, but x has to be having equal intervals. Now, after this, we are supposed to see the formula for interpolation. Now, if you check the Newton's formula, yx is equal to y0 plus, it is read as first leading difference, plus x into x minus 1 by 2 factorial into second leading difference, plus x into x minus 1 into x minus 2 divided by 3 factorial into third leading difference, and so on. It continues. How many leading differences we get? So many leading differences we will take in this formula. Now, before you people get confused, let us see how to find all of this. Now, in the formula, there is something called as x. Okay, now how do we find that x? Now, to find that x, the formula is given here. The value of x to be interpolated minus the value of x at the origin divided by the difference between the two adjoining values of x. Okay, so this is the formula we'll be using. When we start the problem, we'll be able to understand it better. And you have first leading difference, second leading difference, third leading difference, and so on. Now let us see how to find that leading difference. So firstly, whatever x is given in the question, copy down that x into a tabular format, and whatever y is given, take that y values also. Okay. Now after this, we are calculating the leading differences. Now here the value is starting from y0, and how many data we have? We have 1, 2, 3, 4, 5. We have 5 data, correct? So take the differences of y. y1 minus y0, will give you the first leading difference. Okay, first leading difference of 0. So you have to write a small triangle. Below the triangle write 0, above the triangle write 1. So y1 minus y0. So this number minus this number will give you the first leading difference. Then y2 minus y1, again it gives you another difference in the first leading difference. Then y3 minus y2 will give you the next difference, and y4 minus y3 will give you the next difference. So from 5 data we have come down to 4. If you see the result, there are 4 data, excuse me, there are 4 data that is available. So this column is called as first leading difference. Are you all able to follow? Next, second leading difference is both of these data you have to take the difference. So this leading difference minus the first leading difference will give you the first answer in the second leading difference. It is something like this. So you are gonna subtract these two and get the answer here. Again you're gonna subtract these two and get the answer here, and then subtract these two to get the answer here. Okay, now again similarly same for the next leading difference. Take the difference here and get the answer, again take the difference here and get the answer, and the difference here, and finally the answer. So in few cases it will end with third leading difference, in few cases it will go to fourth leading difference. Okay, so this is how we calculate the leading differences. Is the procedure clear of finding the leading differences? Can we go to the problems directly? Now the first problem, interpolate the value of x is equal to 7 for the given information. Now if you see here, x values are 2, 4, 6, 8. They are at a equal distance. Everything has a difference of 2. So 2, 4, 6, 8 are the values. Now if you see the question, they are asking us, we have to interpolate the y value when the x value is 7. Now if 7 is coming here in between, what is the y value that we are supposed to find out? Now for this we will be using the Newton's difference method, and we will be solving. Okay, so firstly we will draw the table and we will solve the table, which means we will be finding the leading difference. So firstly we'll be finding the leading difference for everything. So solution, draw a table where you have x and you have y, and you will have leading differences. Okay, now under leading differences we will see how many columns will come. Okay, so here let us write down the values of x as well as y. So x is 2, 4, 6, 8. Leave a little gap so that you will get the other values in between them properly. Okay, leave one line or two lines, something like that. One line if you leave, I think that would be enough. So the x values of 2, 4, 6, 8 are written. Now corresponding to this, write down the y values. 5, 7, 10, and 13. Now how many data do we have? We have y0, y1, y2, y3. So this practice is same. y0, y1, y2, y3. Okay. Now let us start finding the leading differences. Now the first one here, for the leading differences, maybe we require a little more space. Now that leading differences is written as one triangle and to the power 1. That will be leading difference 1 or the first leading difference. Now here we have to calculate the subtracted values. So firstly y1 minus y0, which means in between these two, 7 minus 5 is equal to 2. Correct? 7 minus 5 is equal to 2. This 2 is the first difference. This is 0. Okay. This is the first difference, the first leading difference. Now in between the next two, 10 minus 7 is equal to 3. This is the next difference in the first one. Next, 13 minus 10 is equal to 3. Okay, so this is the final difference that is available here. Did you all understand how to find the first leading difference? Is it clear or you want me to repeat it again? Okay. Now moving on to the next column. That will be the second leading difference. Put a small triangle to the power 2. You can have another row here to depict first leading, second leading and third leading. Okay, now let us start the values. So now right in between the first two, right in between these two, 3 minus 2 is equal to 1. This will be the this will be the second leading difference. And then the next one, 3 minus 3, 3 minus 3 is equal to 0. So this will be the next second leading difference. We are just subtracting these values, 3 minus 2, 3 minus 3. And finally, now since there is only two values, find the leading difference here. So this will be the third leading difference, and 0 minus 1 is equal to minus 1. So this will be the third leading difference. So this should be triangle, okay? Triangle 3, 0. Oops, sorry, ulta. Triangle, here 0, above is 3. So that will be the third leading difference. So this is how you form or find out the leading differences. Is the leading differences clear? Any doubts in the leading difference? Good. Now, next step. After this, what do? We have to find out x. To find out x, we have to use the formula. The formula is the value of x to be interpolated minus the value of x at the origin divided by the difference between two adjoining values of x. Okay, the difference between two adjoining values of x. Now let us see what all is there, or what does all this mean. The value of x to be interpolated. If you see the question, they have asked us to interpolate x is equal to 7. So the value of the x which is to be interpolated is 7. So the value of x is more important in this method. So value of x to be interpolated is 7 minus the value of x at the origin. The value of x at the origin means whatever is the first data that you see here. Here the first value is 2. So this is the value of x at the origin. So take that value of x at the origin. 7 minus 2 divided by the difference between two adjoining values of x. Adjoining is here, one after the other. So what is the gap between the values of x? That is what is being considered. So the gap between the values of x here is 2. If you remember the class intervals and the class difference that we were finding out, right? So it is 2 is the gap between everything. So divided by 2. Now 7 minus 2 is 5. 5 by 2 is 2.5. So the value of x is 2.5. Understood how to find? This x value is very, very important in the problem because this x value is used very generously in the formula, the main formula. Okay, shall we go to the final calculation? Now the next major calculation that we are supposed to do is the interpolation calculation. Now let us write down the formula. Yx is equal to y0 plus x into first leading difference plus x into x minus 1 divided by 2 factorial into second leading difference plus x into x minus 1 into x minus 2 divided by 3 factorial, excuse me, into third leading difference. Now if you see the question, or if you see the step 1, we have first leading difference, second leading difference and third leading difference. So we are considering first leading difference, second leading difference, third leading difference. So first one will be y0. Okay, the value of y in the first place. So y0 plus x is 2.5 into the first leading difference plus again 2.5 into 2.5 minus 1 into second leading difference and 2.5 into 2.5 minus 1 into 2.5 minus 2 into third leading difference. Now let us start applying all the numbers. So firstly, y0. Let me show you what is y0. Concentrate well. If you understand this formula, then it is just simplification. Okay. So firstly, we have to go for y0. Now, if you see here, the value of y0 is 5. Okay, so in the place of y0 we will be writing 5 plus, next it says x, so plus 2.5 is x, correct, into first leading difference. Now going back to leading difference, if you see the first leading difference, we have 2, 3 and 3. So only consider the first value. First leading difference, first value, that is 2. So that is going to be 2. Okay. Now then after this plus, then it says x into x minus 1. So 2.5 into 2.5 minus 1 divided by 2 factorial into second leading difference. So second leading difference is this part or this column. In this again consider the first value. In this column consider the first value here for first leading difference. In this column consider the value for the second leading difference. And for the third leading difference there is only one value, which is minus 1. Okay, so for the second leading difference we are considering 1, and for the third leading difference it will be 2.5 into 2.5 minus 1 into 2.5 minus 2 divided by 3 factorial into minus 1, that is third leading difference. Did you all understand how to take the values and put it into the formula? Is it clear? Okay, now let us simplify. So 5 plus 2.5 into 2 is 5 plus 2.5 into 2.5 minus 1. So 2.5 into 1.5 divided by 2 into 1. Into 1 means it is the same thing. Okay, so no problem. Then plus 2.5 into 1.5 into 0.5 divided by 3 into 2 into 1 into minus 1. Minus 1, keep it as it is. Okay, you will get confused. Here also do one thing, keep 1 as it is. We will see later. Into 1. Now next 5 plus 5 plus, now multiply 2.5 into 1.5 divided by 2 into 1. So 2.5 into 1.5, 2.5 into 1.5 divided by 2. You will get 1.875 into 1 is as it is. Then plus 2.5 into 1.5 into 0.5 divided by 3. 3 into 2, right? So 3 divided by 6. 3 2s are 6. So what do you get? 0.3125 into minus 1. I'm just simplifying this part here. So 5 plus 5 plus 1.875. If you see here, 0.3125 into minus 1, okay, into minus, okay, 1 second, into minus 1 will give you minus 0.3125. Okay, now here what is going to happen is the final simplification. 5 plus 5 plus 1.875. So yx, finally you will get 11.56. So this is the y value when x is equal to 7. Is it clear? This is how you find the y value when x is equal to 7. The only thing is you have to remember this formula and you have to solve it. Okay, and students, you can send me your assignments after your BE class also. Now concentrate in the class. Did you all understand this? How to find the y value when x is given? Is it clear? Okay. Now we will solve the next question. Now in the first question, if you see, the values were directly given as 2, 4, 6, 8. Okay. Now in the next question, the values are in the form of class intervals. So let us understand how the values of class intervals has to be converted and solved. Fine. So let us see this. Following are the runs scored by different cricketers in a test match. Find the number of cricketers who scored less than 50 runs in the test match. So these are the runs which are scored in a match. We are supposed to find the number of cricketers who has scored less than 50. Okay, here 40 to 50. So less than 50, how much people are there? We have to find out. Okay, now this or such questions where you have the class intervals, okay, you have to convert such full class interval into open-ended class intervals. Okay, now let us see how to do that open-ended class interval. Solution. First, we have to redefine the class intervals. Now, instead of writing 20 to 30, we are going to write less than 30 . Let me rewrite that. Less than 30. So if you see here, 20 to 30, 30 is the higher number. So less than 30 will be the first class interval. I am converting the close end to the open end. Then less than 40. Okay, we have to leave some space in between. So a little less than 40, less than 50, less than 60, and less than 70. Correct? Less than 30, 40, 50, 60, 70. Okay, and if you remember, whenever there is an open end class interval of less than or more than, the frequencies would be cumulative frequency. We used to have the values, and we used to add the values to get cumulative frequency. We used to subtract the values to get back the frequencies. If you remember previous semester, we have learned this enough. So here they have given us normal frequencies. We have to convert them to cumulative frequency. How do we do that? Start with 31. First number will be there as it is. Now 31 plus 42 will give me 73. How did I get 73? 31 plus 42. Next, 73 plus 51. You will be getting 124. 73 plus 51. After that, 124 plus 35 will give you 159. Okay, and finally 159 plus 31 will give you 190. Did you all understand? I hope you remember how to find the uh, cumulative frequency. You just have to add the numbers. Okay, now as usual write your y1, y2, y0, all that number. So for first one will be y0, then it will be y1, y2, y3, y4. Okay, now after this we have to find the leading differences. So the first one will be the first leading difference. Now the first leading difference, we have which two we have to subtract? We have to subtract 73 minus 31, which will be 42. Correct? So this is the first leading difference. Now after this, oops, I don't know what's wrong with this. Wait a minute. Okay, it's okay. Now the second difference that we will be finding is between 124 minus 73, which will give us 51. So you're getting back your frequencies. Okay. Next, 159 minus 124 will give us 35, and 190 minus 159 is 31. Okay, so that will be the leading difference. Next, for the second leading difference, which is 2. So here what is going to happen is, take the other two differences. 51 minus 42 is equal to 9. 35 minus 51, you'll get minus 16. 31 minus 35, you will get minus 4. So this is the second leading difference. Now coming to the third leading difference, the difference between 9 and minus 16 will give you minus 25, and here minus 16 minus of minus 4 will give you 12. Okay, 12 will be the answer. So that is the next leading difference. Until you get only one value, you have to find the leading difference. Okay, now here we have got two values. Now let us find the last value where we have to get the leading difference. So the last value, that is fourth leading difference, is between minus 25 and 12, which will give you 37. This is minus 25 minus 12, which is 37. So this is the final leading difference. Did you all understand this part? How to find the leading differences? When you write it in your book, write it with proper spaces, so that you will be able to know which number comes first and which number comes next. Okay. Now after this, let us find the x value. X is equal to, write the formula once again, the value of x to be interpolated minus the value at the origin divided by the difference between the two adjoining values of x. So you have to write that formula. Okay. Now the value of x to be interpolated. What is the value of x? Less than 50. Correct? Less than 50 is the value which has to be interpolated. So I will take this 50 as the number. So the value that is to be interpolated is 50. And what is the value at origin? Which is the first value? The first value is 30. Okay, so this is the first value. So that 30 should be considered, divided by the value, the difference between the adjoining x values. So from 30 to 40, there is 10 difference. 40 to 50, 10. 50 to 60, 10. 60 to 70, 10. So there is 10 as the difference. So divided by 10. So 50 minus 30 is 20. 20 by 10 is 2. So the value of x is 2. Okay. Now write down the formula to find yx. Yx is equal to, first will be y0 plus x into, x into first leading difference plus x into x minus 1 divided by 2 factorial into second leading difference plus x into x minus 1, x into x minus 1 into x minus 2, wait a second, x minus 2 divided by 3 factorial into third leading difference plus, if you see the leading difference, you have 4 leading differences, right? It's not only 2 or 3. So until how many leading difference you have, so many you have to write. So plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into 4 leading difference. Okay, so that is the formula. Now let us put all the values into the formula. So all the values into the formula starting from y0. Now go back to the question. The y0 is 31. The first leading difference is 42. Second leading difference is 9. Third leading difference is minus 25. And fourth leading difference is 37. Fine. Now we will consider all of this. And we also know what is x. X is 2. Now y0 is 31. Okay, maybe I should use a different color for you to understand. Y0 is 31 plus x is 2 into first leading difference is 42 plus 2 into 2 minus 1 divided by 2 factorial into second leading difference is 9 plus 2 into 2 minus 1 into 2 minus 2 divided by 3 factorial into third leading difference will be minus 25 plus, I'll write it in the next page, 2 into 2 minus 1 into 2 minus 2 into 2 minus 3 divided by 4 factorial into 37. So this is our full-fledged formula derivation. Now let us solve this. We have to simplify. So 31 will remain as it is. 42 into 2 will give me 80. 42 into 2 will give me 84. So first will be 31 plus 84 plus, now let's come back here. 2 into 2 minus 1 is, 2 minus 1 is 1. So 2 into 1 is 1. Okay, so it's something like this. 2 into 1 divided by 2. So, which is nothing but 1. 1 into 9 will give you 9 as the value. You just have to do the simplification then and there. If you are getting confused, do it stepwise. Okay, 2 into 1 divided by 2 factorial into 9. Do it stepwise. If not, you can do it directly also. Now if you see here, 2 into 2 minus 1 is 1. So 2 ones are 2. Then 2 minus 2 is 0. So 0 into anything or 0 divided by any number, everything is 0 only. Fine. So this complete expression will change it to 0 plus 0. Okay. And finally, if you see here, 2 into 2 minus 1 into 2 minus 2 into 2 minus 3. Again, 2 minus 2 is 0. So no matter what you multiply or divide with 0, final answer will be 0. So what is the value of yx now? It will be 124. If you add all of this, 31 plus 84 plus 9 will be 124. So therefore, write the conclusion, number of cricketers scored less than 50 runs in the match is 124. Now from where did we get this number of cricketers and all? See the question. Runs, number of cricketers. So for runs less than 50, we got 124 cricketers who had scored in the test match less than 50 runs. Okay, so that is your problem when they have given you the class intervals. Is it clear? Did you understand how to solve it? Any doubts in this problem? Guys, don't reply to the host, reply to everyone. Good. Now, one more similar question is there. This question is homework for you. I want everybody to use the same method which we did just now and solve and say me this answer before Monday. Okay? Before Monday, keep this answer ready. I will be sending this question in the group. Solve this and say me the answer. Okay, if you did not understand any part of it, or if you have got confused with any part of the problem, the videos will be available on the YouTube. The link will be shared in the WhatsApp group. Go back, check the video, learn where you have got confused. Okay, and make sure you are thorough with this method also. Is it clear? Yeah, we are going to stop here for today. Monday, I'll take one more class.